Hi all, today I'm going to talk about the most basic metal in our lives. The most abundant metallic element and the third most abundant of all elements after oxygen and the silicon. In contrast, the Earth's mantle is only 2%, 2.38% this metal by mass. Logical question, what kind of metal is it? Of course, it's aluminium. I think many of you know the physical and the chemical properties of aluminium. Aluminium has significant safety advantages in protecting food by creating a protective shield against infection and pollution. Aluminium compounds also improve the effectiveness of vaccination and drugs, and aluminium sulfates are used for water purification. Aluminium beverage cans were virtually unknown in 1960s, yet by the early 1970s over 1.3 billion pounds of aluminium had been used for these containers. The reason for aluminium's popularity in the beverage industry are that it's non-toxic, odorless, tasteless, and lightweight. Furthermore, it is thermally conducting, so the field inside the container can be heated rapidly. Advantages. Let's gonna talk about advantages. Aluminium is an infinitely recyclable material, and it takes up to 95% less energy to recycle it than to produce primary aluminium, which also limit emissions, including greenhouse gases. Today, about 75% of all aluminium produced in history, nearly a billion tons, is still in use. The recycling of aluminium generally produces significant cost savings over the production of new aluminium, even when the cost of collection, separation, and recycling are taken into account. Over the long term, even larger national savings are made when the reduction in the capital cost associated with landfills, mines, and international shipping of raw aluminium are considered. Energy saving. Recycling aluminium uses about 5% of the energy required to create aluminium from bauxite. The amount of energy required to convert aluminium oxide into aluminium can be vividly seen when the process is reserved during the combustion of thermite or ammonium perchlorate composite propellant. Aluminium die extrusion is a specific way of getting reusable material from aluminium scraps, but does not require a large energy output of a melting process. In 2003, half of the products manufactured with aluminium were sourced from recycled aluminium material. Environmental saving. The benefit with respect to emissions of carbon dioxide depends in part on the type of energy used. Electrolysis can be done using electricity from non-fossil fuel sources such as nuclear, geothermal, hydroelectric, or solar. Aluminium production is attracted to sources of cheap electricity. Canada, Brazil, Norway, and Venezuela have 61 to 99% hydroelectric power and are major aluminium producers. However, the anodes vividly used in the Herald process are made of carbon and are consumed during aluminium production, generating large quantities of carbon dioxide. Regardless of electricity source, efforts are underway to eliminate the need for carbon anodes. The use of recycled aluminum also decreases the need for mining and refining bauxite. The vast amounts of aluminum used means that even small percentage losses are large expenses, so the flow of material is well monitored and accounted for financial reasons. Efficient production and recycling benefits the environment as well. So, let's explore aluminium recycling. Look at this video. In this video, we're gonna talk about aluminium recycling in England. Novelis is the world's largest recycler of used beverage cans. They arrive at its factory in Warrington, England, from all over the world, compressed into bales, each weighing up to 1,000 kilograms and containing as many as 65,000 aluminium cans. The bales of compressed cans are located onto a conveyor and fed into a 340 horsepower shredder. Aluminium is tricky to sort because unlike some metals, it can be separated out with a magnet. So next, the shredded scrap passes through an optical sorter at a rate of 3 meters per second. The machine uses infrared sensors to sort out what is metal and what is not. Then blast away any plastic or glass with jets of air. A powerful magnet sucks up any scraps of steel, leaving just aluminium. The next problem is aluminium doesn't melt until 660 degrees. The paint and the lacquer aren't so lucky. They are instantly vaporized. The clean aluminium chips are ready for the next stage, melting. Two furnaces hit a blistering 730 degrees and handle up to 100 tons of aluminium each. The trouble is when the aluminium melts, it reacts with air, forming a layer of aluminium oxide that floats on top. This unwanted oxide is known as dross. A brave furnace operator skims it off with a giant steel spatula, and the alloy is ready for the casting area. The only problem is getting there. A river of molten metal flows downhill to a holding furnace that is the size of a double-decker bus. Somehow, they need to pour the liquid metal into a mold. Remarkably, the solution is to tip the entire furnace, and a fountain of deadly metal pours into one of the three molds set 10 meters into the ground. Inside, they will be cast into towering blocks of aluminium. After 2.5 hours, they have three giant aluminium monoliths called ingots. Each one is 10 meters long, weight 27 tons, and is made up of 1.5 million recycled cans. Today, demand for aluminium is so high the ingots don't lie around. Their transformation back into cans starts with a 900-kilometer journey to a rolling mill in Germany. Here, they are heated in another furnace to 525 degrees. This relaxes the bonds between the aluminium atoms, releasing any stresses within an ingot. Then it's passed back and forth through a series of rollers. It is a bit like rolling pastry. Each set of rollers sends out the metal until it's a quarter of a millimeter thick and 10,000 meters long. That's 1,000 times its original length. Massive reels of the aluminium arrive back in the UK at bulk packaging to undergo reconversion into cans and possibly something a little more out of this world. The aluminium alloys for rockets are very similar to the ones used for cans, so theoretically, your old can could be on its way to space. Meanwhile, on planet Earth, they feed the sheets of aluminium into a rapid-fire capping press. This heavyweight knocks out thousands of shallow caps. The secret of turning them into cans is a tight squeeze. Every cap is rammed through a series of rings, each narrower than the last. Forcing the aluminium through the rings squeezes it into a cylinder and a new can is born. They produce around 6.5 million cans here every day and send them all over the world. That's a whole lot of aluminium. Luckily, there is plenty more where this came from. Thank you for your attention. I want to say about aluminium. Aluminium have huge role in our life, and also aluminium recycling have huge role in our life. Thank you. Study chemistry, study smart.